Hello, this is Vedant Rai, SAP ID 60001180061 from B4 batch of TE Electronics. Today I will be presenting experiment number 9 of my DLIC practical. The aim of this practical is to design a PWM using IC 555. PWM stands for a pulse width modulator. This is the internal structure of a IC NE 555. As you can see, it consists of two comparators 1 and 2, one flip-flop here, and it also has a NPN transistor. The name 555 comes from these 5 kilo ohm resistors. The pin 1 is the ground pin, the second pin is the trigger pin. If you give a negative pulse to this pin, it sets the flip-flop. The third pin is the output pin. Here you collect the output and it can be used to drive small circuits. The fourth pin is the reset pin. This is used to reset the internal flip-flop. The fifth pin is called the control voltage pin. This pin can be used to control the timing of the IC. The sixth one is the threshold pin. This pin resets the flip-flop when the applied voltage exceeds 2/3 of VCC. Pin 7 is the discharge pin. This pin, as you can see, is connected directly to the collector of the NPN transistor. The 8th pin is the VCC. We are going to be performing pulse width modulation. It is a method to reduce the average power delivered by cutting certain parts of the input wave. This is because we use this to vary the voltage we are supplying and the power depending on the circuit we are using. We are using IC 555 as a monostable multi-vibrator. This is a major application of the IC 555 and it helps us in making the IC 555 into a PWM. This is a circuit diagram for a monostable multi-vibrator. We will now see the circuit diagram for the pulse width modulator. I'll be using LT Spice. This is the circuit diagram. There's the IC 555 here. I've connected the ground. The trigger voltage I've given a pulse with these characteristics. 5 volts initial voltage, 0.05 milliseconds delay, 500 cycles. And to the reset I've given the plus supply, positive, V out. Used a 10 kilo ohm resistor and a 0.1 microfarad capacitor. The modulating signal is of amplitude 1.5 and frequency 40 Hz. I will run this now and check the output. First we'll see the modulating signal, and as you can see it is a regular sine wave. We'll now check the trigger voltage. This is the trigger voltage. This is exactly what we are expecting. As you can see, these pulses which we are supplying. And finally we will see the output voltage. This is the output voltage. If I remove this, you can clearly see that you're getting pulses of different width, which is exactly what we were expecting. Hence the input wave is modulated and the power supplied is also varying depending on the width. And as per the output circuit we are using, or whatever we are using this pulse width modulator to drive, we can accordingly adjust its values so that we supply the required power. That's all for this experiment. Thank you.